Hey, we are back to the Surface Pro. Yay! All right, guys. So we are starting trigonometry. Super excited for this journey with you. And what the heck is it? Trigonometry is the study of the relationship. Okay, so write this down with me, please. The study of the relationship between the side lengths, I'm going slow so you can keep up with me, the side lengths and angle measures of a triangle. So it's the study of the relationship between the side lengths and the angle measures of a given triangle. So here's our triangle over here. Notice theta. Okay, so this is theta. That means that's your reference angle. That's the angle that we're going to pull all of the different trig functions from. Okay, there's theta. It's spelled T-H-E-T-A. You might see beta. These are all Greek letters in the Greek alphabet. And you'll see alpha also. There's more, but these are the main ones that we use. Okay, so sine, cosine, tangent. Let us remember, please, there are 6 main trig functions. For the purpose of our review today, we are going to use angle A, or theta, as our reference angle. Now, the 6 main trig functions, they are applied to the angle measures. Okay, you can't take the sine of 1/2. Doesn't even make sense. Okay, they are applied to angle measures, and their purpose is to give us the ratio of the side lengths. Okay, it gives the ratio of the side lengths. We will never say, oh yeah, what's the cosine of rad 2 over 2? Okay, again, it doesn't make sense. The cosine is applied to an angle measure. The cosine of 45 degrees, that's rad 2 over 2. All right, so let's review. Sine, cosine, tangent, SOHCAHTOA. So the sine of theta is our opposite leg over the hypotenuse. Okay, for our triangle over here, the sine of A would be little a over little c. And notice, all the angles are capital letters and all the sides are the lowercase. The side across from the angle is called its corresponding side. Okay, the side across from the angle is the corresponding side. If I needed to find the cosine of theta, cosine is adjacent over hypotenuse, so A over H. For our example, the cosine of A would be little b over little c. Reminder, your hypotenuse is always the leg across from the 90-degree angle. It is always the longest side. All right, and tangent. Tangent is opposite over adjacent. So for our example, the tangent of A is little a over little b. Okay, those are the first 3 main. They have reciprocals. The reciprocal of sine, go away, little button. The reciprocal of sine is cosecant. Okay, so that's hypotenuse over opposite. The reciprocal of cosine is secant. So that is hypotenuse over adjacent. And the reciprocal of tangent is cotangent. Oh, golly, sorry guys. Okay, so the cotangent of theta is adjacent over opposite. Again, these are your reciprocals. Okay, they're not inverses. They are reciprocals. We do have inverse trig functions. Okay, and those are to find the angle measure. Okay, so they are applied to the side ratios. And they give us the angle measure. So it'll look like this. The inverse of sine of the opposite over the hypotenuse will give us theta. inverse cosine is applied to adjacent over hypotenuse, and that gives us theta, or the inverse tangent. Okay, so again, it's applied to the sides. All right, let's play with it. Here we go. Find the value of the 6 trig functions for angle theta. Notice that's right here. Here we go. So the sine of theta is the opposite over hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. If you can reduce, you must. In this case, we can't. Okay, so that's all right. The reciprocal cosecant of theta is the reciprocal, so 13 over 5. Secant of theta is the reciprocal of cosine, so 13 over 12. And the cotangent of theta is the reciprocal of tangent, so it's 12 over 5. Now let's say that we are asked to find, example number 2, tangent of A when cosine is given. Well, I don't have a triangle, so let's draw it. Okay, so here's my triangle. We are dealing with right triangles because we're using sine, cosine, and tangent. Ladies and gentlemen, you cannot use sine, cosine, tangent, the reciprocals, and the inverses on a triangle that is not a right triangle. It must be a right triangle. You should write that down. Okay, so cosine we know is adjacent over hypotenuse. So this is the adjacent and this is the hypotenuse. But if I am asked to find the tangent of A, I also need the opposite side. How do I find a missing side in a right triangle? Dun, dun, dun. We are going to use the Pythagorean theorem. A squared plus B squared is equal to C squared, ladies and gentlemen, only with a right triangle. Okay, so A and B, those are the legs. C is always the hypotenuse. Now, it doesn't matter which leg you put where. For now, I'm just going to put it as A. So we get 4 plus B squared is equal to 9. B squared is equal to 5. B is equal to plus and minus the square root of 5. But this is distance, so it's just a positive rad 5. Cannot be the negative also. All right, so the tangent of A, now that we have the opposite side, is going to be rad 5 over 2. We don't need to rationalize because the radical is not in the denominator. Beautiful. All right, if you go to the second page with me, it's asking us now to find x. X in this case is the angle measure. Okay, so we're using the inverses. So I need to find the inverse sine of 0.7590. And I'm going to go to my calculator. So pause if you need to, grab your calculator. You'll notice you have sine, cosine, tangent, and then above it are your second functions, inverse sine, inverse cosine, inverse tangent. Okay, so go ahead and put second sine so that you can get the inverse, and put in 0.7590. Now, if you're using a scientific calculator, in the upper right-hand corner, it should say DEG for degree. We're dealing in angle measures that are degrees, not radians. If it says rad, you need to change it. Okay, for those of us with the graphing calculators, hit mode. Your word degree should be highlighted, not radian. Okay, we'll deal with radians later, and it matters, okay? So if we press enter, we would get, if we round to the nearest degree, about 49 degrees. Inverse functions help us to find the degree measure. Excellent. All right, last but not least, and again, this is review. We are asked to solve. If you're asked to solve, that means you need to find all the missing pieces. A triangle has 3 sides and 3 angles. In example A, we're given all the sides, so I don't need to worry about that. But I'm not given any angles. So, I'm going to use angle A first. And I need to find it, but I'm given all 3 sides. So I could use sine, cosine, or tangent. Let's use cosine. So the cosine of angle A is adjacent over hypotenuse. But I need to find the angle. So I'm going to use the inverse cosine of 9 over 15 equal to angle A. I'm going to go to my calculator. I'm going to make sure I'm in degrees. I'm going to put the inverse cosine of 9/15, and I get that angle A is approximately 53 degrees. Now at this point, I could do two things. I could go to angle B and use another trig inverse to find the angle measure. Or I could remember that the two non-right angles in a right triangle are complementary. They add up to 90 degrees. So the measure of angle A plus the measure of angle B is going to equal 90 degrees. I know that angle A is approximately 53 degrees. So then I can conclude that the measure of angle B is approximately 37. And the reason you have to say approximately is because you used angle A to determine angle B. Angle A is already approximated, so keep it consistent. Nice job, guys. All right, last but not least, we are given one angle, well, technically two, and the hypotenuse. So using the idea that the measure of angle X plus the measure of angle Y is complementary, and I know that X is 63 degrees, we can then conclude that the measure of angle Y is 27 degrees. I do not need to approximate because the given was exact. All right, I then need to find a side. So I'm given this angle and I'm given the hypotenuse. Let's find little x first. So that means the opposite and the hypotenuse. The sine of 63 degrees is equal to the opposite over the hypotenuse. I'm going to multiply both sides by 23. And I get that, let me just write it out so you guys can see what I'm putting into my calculator. We're not using the inverse. No. And it says to round to what? The nearest tenth for the sides. Okay, so 23 times the sine of 63 degrees, my calculator is in degrees, is approximately 20.5 units. I could also, I could now use the Pythagorean theorem if I wanted to, because I know that little x is 20.5, or I'm going to use cosine, because the cosine of 63 degrees is the adjacent, which is little y, over the hypotenuse. Again, I'm multiplying 23 to both sides. Write it out so you guys can see it. And then I'm going to round to the nearest tenth, so 23 times the cosine of 63 degrees, not the inverse, because I'm not looking for the angle measure, is approximately 10.4. When you are solving triangles, please write all your found answers together in one fantastic little spot. And yeah, in case you haven't figured it out yet, it is definitely not drawn to size, our triangles. All right, guys, that is our intro to trig. Hopefully it was a review. You have this if you need to rewind and whatnot, but now you can start homework number 1. Good luck.